Hello children, hi, welcome to Maverick Masters Academy. I am Kranthi Kiran. I am going to deal with the physical sciences of JEE coaching. So here, today we are going to discuss electrostatics. So before getting into detailed problem solving of these JEE mains, we have to understand what exactly is electrostatics. What are we going to deal with these? What are we going to deal with in this particular chapter? At first, I wanted to say my real life experience where I have encountered this while I'm sleeping. When I'm sleeping during my winters, I used to cover myself with a blanket. So when I was sleeping in the dark, I used to rub my hands upon this blanket which I am covering up. So then I used to hear some kind of sparkling sound, and sometimes I could see them sparkles, little sparkles which happens upon that woolen blanket which I am covering up. So why does this happen? This later on, when I grew up, I used to do again and again during my childhood, but I don't know what exactly is the science behind that. But when I started learning physical sciences, then I got to know that there is a phenomena of charge transfer from one body to other body. This is what this kind of charge transfer phenomena we are going to discuss in this electrostatics. And one more real-time example, how the lightning occur. When the clouds move, they accumulate lot of charge upon them. The negative charge and positive charge, it's keep on accumulating. I'll discuss what is this negative charge and positive charge, but I have to say how exactly this lightning happens. When these clouds move, they accumulate lot of charge upon them, and they accumulate positive charges, negative charges. At the time, the earth, it is a wonderful ocean of electrons. It keep on acquiring electrons. As the ocean, if you observe ocean keep on absorbing the water. All the water flows into ocean, right? Similarly, the electrons will start always moving into the earth. Okay. So when these clouds are moving, wherever there is huge charge accumulation there, if you observe, generally the raining happens at mountains or ghats, wherever it is, ghats, western ghats or eastern ghats. We have so many ghats and mountains. There the raining happens generally. In general, the huge raining will happen at those places, because the distance between these clouds and the land will decrease at those places, and there is easy way to pass this negative charge from clouds to earth. So these negative charge, whenever they pass into the earth, it's a huge charge which moves from cloud to earth, causing this lightning which we see. This is a real-time example where the charge transfer is taking place. So like this, there are wonderful examples in the real life where we see this charge transferring happen. The sparkle sound, sparkles, we'll see sparkling sound, we see sparkles, we listen sparkling sounds in the real life. So all these kinds of phenomena will happen in the real life. One more example, let's see. Usually the girls or mom in our home, the ladies, generally they wear these saris, polyester saris. These saris do accumulate some kind of charge while they are working, they are doing some job, and whenever they are touched by some other hand or some other body, the charge gets transferred, and you can feel that spark while the charge transfer happens. So these kind of phenomena happens in a real life. Now I am going to say ancient example. In the Greece, this example which is from Greece, and with this example I am going to say from where the word electro has come. It has arisen from a term called electron. Sorry, let me write like this: electron. You know what exactly do you mean by electron? You will get to know from this incident or example which has happened around 600 BC in the Greece. You know, there in the Greece, the people used to party a lot. The ladies, the royal ladies, rich ladies, they used to wear a lot of jewelry on them. That jewelry contains amber stones, you know, amber stones. Amber stones, it's a kind of stone which we use as a gem, you know, which is in the color of honey. It will appear in the color of honey. These amber stones will be in their jewelry, and while they get bored in the party, what they used to do, you know, they used to have frogs in a simple basin kind of thing, and they touch those frogs with these jewelry which they have upon their body, and those frogs will start jumping, you know, like they got an electric shock. If we get electric shock, we'll also jump. Similar way, those frogs used to jump because of these amber stones. When jewelry which was made with amber stone touches the frog, then they observed this strange phenomena from frogs. They used to jump. From there, in Greek, the amber is called as electron, and from the term electron, they have coined the term electron at the time. From that electron, this term electro, which is equivalent to charge now. Whenever we want to say something about charge, we'll use this term electro or electron, whatever it is. So we'll use this term. Now we shall try to understand some information about this charge in the introductory class of this electrostatics. By this time, I hope you have found some interest towards this electrostatics. What exactly is making these charges to get transferred from one body to other body? How exactly these charges gets transferred from one body to other body? We shall see now. First of all, there is a wonderful example. Again, I'm going to give you. See, the introductory class is such a class which makes you keep interested towards the subject, grounded towards the basics of that particular topic. So you have to be sound and be patient with the introduction. Try to listen to the introduction classes of every chapter, which makes you interested in that particular topic, to solve the problems, to listen to the classes further. Okay. Now we are going to see three different phenomena. You know, you take a glass rod. Let me take a glass rod. And what you do, you just rub it with a silk paper or woolen paper, woolen cloth or silk cloth. You just rub it. Rub with silk cloth. Then what happens to this glass rod? You see, you take this glass rod, and let me take one more rod, because in order to explain this phenomena, I have to have this setup also. Let me take a plastic rod, and again rub this with silk. Rub with silk. You know, this glass rod acquires some charge and plastic rod acquires some charge. And what exactly happens when these two rods, when they are brought together, they attract each other. And interestingly, when you perform the same procedure for one more glass rod, rub it with a silk, or here also you take a plastic rod and rub it with silk. And as I told you, when you rub with silk, these rods, they gain some charge. When these two plastic rods, they brought together, when they are brought together, they repel each other. Even these two glass rods, they repel each other. You know, this silk cloth and the silk cloth which you have used to rub these two silk cloths also, they, I mean, what we say, repel each other. So why is this happening? What exactly is making these rods to attract and repel each other? See, these two rods, they got attracted, and these two rods, they got repelled, and these same plastic rods, when they are rubbed with silk, they also got repelled. So what is happening? What exactly is making these two rods repel or attract each other? You see here, the glass rods, when they are rubbed with this silk, I mean, when you rub or produce a friction upon this glass rod, you see, these glass rods, they gain a charge. These glass rods gain a charge called positive charge. Initially they were not named as positive and negative charges. As I told you, they are not named as positive and negative charges. You see, this plastic rod gained negative charge and this glass rod has got positive charge. Why exactly this has happened? You know, the electrons, you know, the charge carriers, the electrons, they got transferred from this glass rod to the silk. Here if you see, from the silk cloth, the electrons got transferred onto this plastic rod. That is why it has got negative charge, it has got positive charge. Clear? So it has got positive and it has got negative charge. Now you see, as it is positive, it is negative, they are attracting. Means from this you can say that unlike charges, they attract. Unlike charges, attract. Unlike charges, see, this glass rod and this glass rod, they are repelling each other. Why? Because these two charges has got same charges. These two rods have got same charges, so like charges do repel. So this is an interesting observation which was done in the activity where the like charges will attract and unlike charges would repel. You know, these charges, you know, when they are brought together, they get nullified, you know. But when this positive charge gets attracted towards this negative charge, these two charges, when they interact with each other, these two charges will get nullified. That is the reason there is a great scientist called Benjamin Franklin who has given the name called positive and negative charges. You know, initially they used to say whenever it was rubbed with the silk, whenever these rods are rubbed with silk, they are gaining charges, right? So when they gain charges, this gaining of charge is named as electrification. What they have called it as electrification. This is what happened with the frogs. Even in those parties, when the frogs used to jump, they used to gain these charges. They get electrified by transfer of the charges from amber. Next, I have to say about this particular title. Now I have discussed enormously about these charges getting transferred and all, right? But this electrostatic is nothing but when the charges are in static condition. When charges are in static means which is motionless, in static, not moving. Why? The charges will keep on moving. If you see, the charges will be keep on moving, but here you have to understand that you will compare the movement of charges with respect to time. Charges are in not moving condition with respect to time. So this is what we are going to study in this particular chapter. When the charges are at rest, how exactly they behave, what they do produce, what kind of forces they produce, what kind of fields, what kind of potentials they produce. So all these you are going to study in this particular chapter. And next to this, I want to say how exactly we can electrify an object. What are the ways to electrify an object? I'm going to say that. You will be eager to solve problems, but this is very necessary in order to proceed to solve problems. First of all, you have to be clear with the basics in order to solve the problems. So in this particular topic, you have to understand how a body can be electrified. In that, I have to say, one it is friction and other one it is conduction. Next one it is induction. So conduction is nothing but which happens in the case of conductors, where these conductors allow the charge to pass through when they are in contact with other body. That is conduction. When in the case of friction, if you see friction, as I told you, when you rub something, this happens in our real life even. The friction, when you have a comb with you, you just rub your comb, upon your head, and these comb will acquire some charge, whether losing electrons or gaining electrons, whatever it is, it gains some charge. After that, when it is taken towards the pieces of paper, it starts attracting, by frictional movement, the comb has acquired charge upon it and it is able to attract these pieces of papers. And last one, that is induction. This is what we are majorly focused upon. What is induction? How exactly you can do this induction process? Induction is not by touching or friction. It is just keeping the charged particle beside it and creating charge on the other body. For this, I am going to explain you an wonderful example. Okay, what you do, you take two bodies. Okay, you take two bodies which are intact with each other. Both are intact with each other, they are touching each other. Now what I'm going to do is, I'm just taking a rod, a rod which is positively charged. Remember, which is positively charged. This rod is positively charged. Just I'm bringing towards A. Now what happens, as this is positive charge in this rod, it starts attracting the negative charges within A. So the A will have all the positive, negative charges, plenty of positive and negative charges. Remember, let me write a designate with another. So positive and negative charges upon them, which are distributed evenly within the body. Positive and negative charges like this. What happens when a positive charged rod is brought near these two, what we say, bodies? Now if you bring these two positive charges near A and B, then this positive charge will repel the positive charge, and immediately what happens, this entire phenomena will happen within the fraction of seconds. Okay, it won't take much time. Instantly, as soon as you bring the positive charge, this happens. Okay, now immediately the negative charge will start accumulating, because this rod contains positive charge and the negative charge will be accumulated over here. That doesn't mean that there is no positive charge over here. The positive charge will be repelled. See, the entire negative charge from the B also, because these two are metallic balls, so the negative charges will keep on moving from ball B to ball A. The negative charges will keep on accumulating over here. But after some time, you see, these negative charges, when they start accumulating over here, they'll repel each other. The negative charges will repel themselves each other. So this negative charge will start repelling, some negative charge will move away. All the negative charge won't be concentrated over here. because these negative charges, they themselves will repel. After some time, this attractive force and the repulsive force between these negative charges, they will get balanced, and a state will be obtained such that all the negative charge will be accumulated, and at B the positive charge will be accumulated like this. There will be positive charge upon B. Now what you do, simply you separate these two charges without taking this rod from this place. You know, rod must be placed over here itself. Rod must be placed over here itself. Then it must not be touched, okay? It must not be touched. If it gets touched, the negative charges will jump into this rod, okay? Because they are conductors, this negative charge will get transferred into this and nullifies this positive charge. You know, you see here, now the positive charge got accumulated, and indirectly this body is negatively charged now, and this body is positively charged. You have separated, no more charge transfer will take place. So indirectly you have induced a positive charge. You polarized these two bodies. You have made this as a negative body and this as a positive body without even touching this glass rod to A and B. This kind of phenomena is called as induction. Now you have learned how the charge transfer takes place with in different modes. Now I am going to discuss somewhat basic. You know, a physics class is not at all worthful if you don't solve a problem, right? So we shall solve a problem, very simple problem, basic problem. We shall solve a basic problem. And one more star point I am going to tell you, very important point. This is the one you have to remember. While the charge getting transferred, the negative charges, electrons would get transferred from one body to other body. While the electrons are getting transferred, remember, while the charge is getting transferred, mass is also getting transferred. When charge gets transferred, mass also gets transferred. Remember this. Why? Because with every electron there will be some minute mass which will be passing into other body, that is 9.1 into 10 power minus 31 kilograms. This is mass of an electron. Remember, mass of proton is 1.6 into 10 power minus 27 kg. So this mass of electron, whenever the electron gets transferred from one body to other body, indirectly you are transferring this mass to the other body. So when the charge gets transferred, the mass also gets transferred. Remember, they will ask you a question like this, you know, there are certain number of electrons got transferred from one body to other body. Will there be any change in the mass? Yeah, absolutely there will be change in the mass if the charge has got transferred from one body to other body. Remember this. Next to this, I am going to discuss the mathematics behind these charges and all. For this you have to understand the charge of an electron and a proton, charge of a positive particle, charge of a negative particle, whereas the masses would be varied. You know, the proton is 1000 times more heavier than electron, whereas the charge, you remember, the charge is same for both proton and electron. Proton and electron, they carry same charge, that is 1.602 into 10 power minus 19 coulombs. Remember, coulomb is a charge, unit of charge. Coulomb is a unit of charge, SI unit of charge. If you are discussing about the charge of an electron, you will say that minus 1.6 into 10 power minus 19 coulombs. If you are discussing about the charge of a proton, you will discuss 1.6 into 10 power minus 19 coulombs of charge. Remember this. And it's very simple. If you want to add the charges, it's very simple. If the two protons are present, then if let us suppose the charge is taken as E. Charge is given as E. If it is in the case of proton, if it is E, and if it is in the case of electron, it would be minus E. Remember, charge is given as E. So if he wants to calculate what is the charge of two electrons, then simply you multiply 2 into 1.6 into 10 power minus 19 coulombs. Next to that, addition, simple addition. It can be added, okay? 1 coulomb, 2 coulomb, 3 coulombs of charge. So how much coulombs of charge is present? Simply you can say there are some like 6 coulombs of charge. You can directly say if 1 q of charge is present, 2 q's of charge is present, 3 q of charge is present, minus 2 q charge is present, then simply it's simple kind of addition. If this minus 2 q denotes negative charge and these 3 denotes positive charge, you can simply say 1 plus 2, 3 plus 3, 6 minus 2, 4 q charge. You can simply do this kind of calculation like simple addition and subtraction kind of mathematical operation while calculating the total charge. Now, after knowing this, you must know one important law, that is law of conservation of charge. Remember, law of conservation of charge. What exactly this law of conservation of charge say? Charge is neither created nor be destroyed in an isolated system. Remember, which is not under the influence of any other system. Means no other body is touching it, no other body is near to it, nothing is near to it. It's an isolated system which is separated from all other objects. Isolated system. The charge always remains same. The redistribution happens, if 2q, 3q, 4q, 1q, like this, and there is a redistribution in this particular body, that is 3q, 2q, q, and you must know what is the other charge which is present within the body. Q is indication of charge, that's all. 3 plus 1, 4 plus 4, 8 plus 2, 10q of charge is present in this body. If this charge redistribution happens, no charge will be newly created. The charge transfer takes place. The charge will move from one body to other body, but no new charge will be created. If you see, a glass rod is there. Upon this, it has accumulated positive charge. That doesn't mean that it has got a new positive charge upon it. It has lost some electrons. It has lost some electrons to the other body. That is the reason it has got positive charge. That doesn't mean, if it is gaining a positive charge, that doesn't mean that a new positive charge was accumulated on that body. Now you see, 10q charge is present within this body. If the charge redistribution happens within this isolated body, what is the x charge which is I have questioned here? As there is no change in the charge in the isolated body, obviously 5, 6, it will be 4q. So you can say like this, in an isolated body, no charge will be created or destroyed. Neither charge be created nor be destroyed. Now we shall come to an important topic, that is quantization of charge. If you see, the charge of an electron is 1.6 into 10 power minus 19 coulombs. So if you are calculating this charge to 1 coulomb, so how many number of electrons? If one electron contains this much amount of charge, 1 coulomb will be made by 6 into 10 power 18 number of electrons. So these many number of electrons would make 1 coulomb of charge. So this much amount of charge is very big when you are dealing with electrostatics. So generally we go with very small charge, that is 1 microcoulomb or 1 millicoulomb. Okay, remember this particular thing, we deal with very small units like 1 microcoulomb and 1 millicoulomb. Now let me go into detail of this quantization of charge. Quantization is nothing but which has a fixed value. Anything in science, if you say quantization which has a fixed value, then that is called as quantization. So if you see here, the charge always appear when you see in a macro scale, the charge always appear in the integral multiples, of electron charge. That is, Q is equals to N. If Q is a charge, total charge, it always gets multiplied with an integer like 1, 2, 3, 4 like this. Electron, this E is a charge. It can be of charge of proton or charge of electron. Okay, we shall solve some problem based upon this concept. There might be a question like this: if a body has a charge of 9.6 into 10 power minus 20 coulombs, whether it is possible or not. This kind of question can be framed. Okay, if this is the charge of a body, then it is possible or not. Then you try to calculate the total charge is given 9.6 into 10 power minus 20, then N into the charge of an electron 1.6 into 10 power minus 19 coulombs. You just calculate it. N is equals to 9.6 into 10 power minus 20, which is divided by 1.6 into 10 power minus 19. 1.6 into 6 times, it is 9.6. 10 power minus 19 gets cancelled as 10 power minus 1, that is 0.6. Here, if you see the N value which you have obtained, it is 0.6. It is neither 1, 2 or 3 or something like that. It is a fraction, 0.6. It is never be possible when you are dealing in a macroscopic level. So, the quantization of charge is failing over here. So, it is not possible. In the next class, so after completion of this, I want to say in the next class we are going to discuss Coulomb's law. So be ready for that lecture. Bye bye.